Good morning. So much for reliability in electronics, right? So, Lip-Bu, let's talk IoT, because IoT is the very big buzzword these days, and it's first of all, it's undefinable, but it's got a lot of very vertical type of versions, different markets that are starting to play into it, and probably at different speeds. So why don't we look at some of the most popular ones? Automotive is one that always comes to mind these days, simply because they're moving from ECUs into SoCs. What's unique about that market that defines it from other markets from your standpoint?
So you talk about the IoT, but more specifically on the automotive. I think automotive, I mean, the more you think about it, is reliability is very important, safety is very important, and clearly, they have a lot of gadgets, and then more and more into the electronics. And I drive a Tesla, so I love the autopiloting and ADAS, but it's still in a very primitive stage. You still have to put your hand around just in case, and but it's kind of fun, to have some of this electronics. So I think it's really a system of system, and it's complex. And so the big challenge is more in the software and hardware, verifications, and make sure that it's reliable, and the safety is very important.
Well, this is one of the first markets that we're getting into where we are really dealing on a mass scale with safety critical type of design, right?
Yes.
So what has to happen on the design side to make sure that the same kinds of chips that we know fail in every couple of years in our smartphones will last for 10 or 15 years?
Yeah, so I think, as I mentioned earlier, the hardware, software, co-design, co-verification become critical. And for safety, reliability, you can check as much as you can, but still some risk. And so I think we're basically helping, and then some of the tier one and also some of the automotive company, they are more direct. And so they all come to a conclusion, certain component, they had to build their own custom ASIC, and especially in the ADAS related, autopiloting related. And so those are the things that is critical, and Semiconductor play a very important role for that. And that's why I think we're excited about the opportunity. And then the other part, I think, is a lot of more software requirement. And so it's a very critical, and also some of the IP block become very important. And so I think it's a combination of multiple function. And you mentioned earlier, had to keep for 15 years. So some of this, become very important. The security inside the silicon become very important to make sure that, it's really, reliable. And now a lot of things to the cloud, and even more important right now, you don't want to have your car being hacked by somebody. And
for us, this is to some extent theoretical, though, right? Because we've never really had chips go into markets that involve safety that have to be around for 15 years. We can only predict that and simulate, saying, this is what it's going to look like in 15 years. Here's what we know of all the effects. How do we guarantee that we have enough coverage there?
Good question. So right now, I think we have a lot of customers. They are providing the silicon to the automotive sector, and so we work with them a lot. But lately, a lot of requirement on function safety, ISO 26262, and some of the requirement is embedded in the process in our tool, and then just make sure that their silicon develop and they can keep it for 15 years, 20 years, 30 years. And so I think you're going to see more of that requirement.
Is it more a question of they have to do more with the tools, they can't push the designs out as fast, or do we potentially need new, more sophisticated tools?
Yeah, so I think first step is to embed it into our tool to help them. And then the other part, they themselves also starting to build how do you put security embedded into the process so that if something wrong, from which chip and what number is this, so that they can keep track of it. And so I think it's a combination from our customer and ourselves to work closely together, to collaborating, work on some of this design, provide the safety, the reliability needed.
The security that you brought up is interesting for a variety of different reasons, not just is the part the right part and was it manufactured under strict control. It's also now a question of can we design that security into the architecture so that it is secure all the way through end to end and with repeated downloads of software.
Correct, correct.
Do we have the capabilities now? Is that something brand new? Is it something that we have to develop as we go forward? I mean, to some extent, this is a learning experience for everybody.
It's a learning experience, yeah. So we learn with our customer and the tier one and then some of the automotive directly. And for them, they also try to learn because there's a lot of new electronics that they don't have to deal with before. And so like I mentioned earlier, ADAS and then the autopiloting, there's a lot of more processing, machine learning, intelligence. And so those are the things that we're learning with them. Along the way, we're starting to suggest some of the features they should have. And then likewise, they were asking us some of the features that they want to build in. And so along the way, we're going to starting to embed that into our tools and or some new function requirement that we need to provide.
What are you hearing back from the car makers in terms of these things better be reliable? We're going to get sued, and by the way, so might other people as we go forward. I mean, this is a classic new risk case for business that never existed before.
Yep, and then we face that a lot, and so clearly everybody is trying to pass the risk to somebody else down the food chain, and so, some of the things the risk you may not, anticipate it will happen, and then so it's better to kind of proactively addressing the checklist with them, and then make sure that our tool can provide, and then who take the risk, who share the responsibility. And again, I mean, sometimes you just have to do an extra mile, and sometimes it's always something go wrong, the down in the food chain, you could get blamed first. And so you just have to make sure that, proactively work with them, and some of the things that they may not even anticipate, and so we have to just, it's a learning curve.
Well, these are also new relationships too, right? That we've never experienced before. How are they reacting to dealing with EDA, for example, and IP vendors that they've never even thought about before?
Yeah, in fact, recently I have one big meeting. It happened that the president is a good friend of mine of the automotive company, and I request for the meeting, and they are nervous and we're nervous, and because they are not quite sure how to deal with the EDA and IP, because they usually deal with the tier one. And but surprisingly, after 3 hours of discussion, we found out 3 action items we're going to follow. And they are excited about what we can offer. And we're excited about this new relationship that we're going to learn a lot. And so I think it's just a beginning, the second ending. So there's a long way to go.
Let's move into another piece of the market, which is the consumer space. When we first started hearing about IoT, it was always going to be the smart refrigerator, which could tell you when your milk was out. Well, turns out people don't really need that. Wearables, another issue. But one thing that does run across a lot of these devices is power. And power seems to be a gating factor in almost every industry that is affected by IoT, from the cloud all the way down to the wearable devices. How do we improve the power? Can we, is that now getting designed in there? Are the tools there? Is the understanding there from the IP and all the ways that things go together?
Yeah, that's a very interesting topic. I mean, clearly, I have my iPhone. By 11 a.m. is run out of battery, because unless you shut down all the apps that I open, and so the ad just keep increasing. So I just keep add on to it. So I think it's a real problem. And clearly from the tool side, we try to figure out, working with the customer, a lot of technique and secret, in terms of switching off some of the not necessary requirement action so that you can save the power gating. And there's a lot of techniques. We work on it and using our tool with our customer. And then meanwhile, we're also looking at some of the new technology. I just funded by, just from the Warden side. As you know, I have 2 jobs. So on the Warden side, we look at some of the new technology. So lately, I just funded a company doing the near threshold voltage asynchronous. So basically, it's go below 0.3 volt. As you know, it's very difficult to do. But this team is awesome team. And so like your dumb refrigerator you talk about, that you don't have to send a package so frequently in high speed. Just once a while checking and then send some package out. And then the idea you're going to be last 5 to 10 years. And that's something that's really intriguing. So I'm excited about this team. They're going to solve that problem. There's another team I was just looking at, I haven't invested yet. It's basically to absorb the power from the ambience. And that's exciting to me. So that means that you don't need to have a battery. And so again, from the tool side, we try to figure out all the best technique to help our customer. And meanwhile, we look at new material, new technique, new architecture, and new material to drive that. So I think power is a real issue. And then some of the application, it really depends on the application. Mobile is one thing. And then some of the device, maybe just send package rather than the pulse package. You can a little bit more low level, sending messages. And that hopefully can last longer because you won't burn so much battery. And then, IoT is great. They collect a bunch of information, and a lot of time, I wear Fitbits and a bunch of others. And frankly speaking, there's only two factors. One is social media, and that's how I communicate with my kids. And then also from our team members, and we try to make sure that all our team members are healthy, and they exercise regularly. But this is a marathon, 10, 15 years, 20 years marathon. So I want to make sure all my team are healthy, and then we are kind of a secret competition, but it's healthy competition, and at least remind someone that you are quite behind. You better do some exercise or walk a few blocks, And so those are the things that's helpful. And then the other part is more collect the data so that you give you more informed information, especially in the medical related area. And we can talk a lot more. I'm intrigued with that, but I think it's all collecting data. And then frankly, the most important area is the cloud. And that's why I think it's implied into the huge cloud infrastructure changes. And there's a sea change happening right now.
You've talked in the past about medical being really the killer app for a lot of the wearable devices, particularly the wrist-based devices. It seems to be moving. I thought I'm hearing birds in the wild here.
Yeah.
Sorry. It seems to be moving a lot more slowly. Is it just a matter of the sensors aren't ready, they aren't low enough power? Is it a matter of regulation? All of the above? What's slowing this down?
I don't think you're right. And I'm really excited about the whole medical space. Give you one example, using the semiconductor process. And if you're not familiar, you guys should look up into Berkeley Lights. And is a professor with 5 patents, very powerful patent. So it's doing this microfluidic optical process for single cell development and to cure cancer. And in fact, we have announcement with UCSF, and then they send real cancer tumor to us. And then we're using massive parallelism processing. So one of the hospital, they have 300 kids have cancer, and you need to process parallelly that cancer in less than 6 hours.
Just so much data that has to be processed?
A lot of data. And then in fact, this company, I told them, don't outsource your data because build a software team and really keep those data because those become very valuable because it will be the data analytics. And then so that, let's say, Mr. X have a cancer, and this is what the data look like, and you can see the cancer cell jumping up and down in our machine. And in the way you can kind of take the good cell and then strengthen it and then send back or inject back to fight the cancer rather than use chemo, and that make your whole body weak, and good cell and bad cell all weak. And so that to me is really exciting to me, and using semiconductor process, and in some ways IoT that collect data. And there's a huge sequencing that you have to analyze. And there's a lot of data analytics behind, and that's where some of the big guys you can know in Cupertino and in somewhere nearby. And so they are all spending a lot of time trying to own that space because that is not just cancer treatment, there's a lot of diseases. And that can be really identified earlier and then find the drug to treating it and how much dosage you have to put in based on the patient's situation so that you can really have a lot of machine learning and intelligence to make the right decision and help the doctor to do that. So I think all in all, I think the whole medical field, and by the way, the margin is much better and in compared to IT. And so they don't buck you every year to lower the price. To them, time to market is more important. Save a life is more important. And I like that.
And this has been evolving for some time now, though. I mean, I've sort of started hearing about this going back as early as 2000, 2001, where people were starting to do this kind of stuff. It's finally getting to the point where it's usable with a wristband type of sensor where they can monitor your heart and tell you if you're going to have problems 24 hours in the future. That still isn't quite there yet. Where are we on that track?
Yeah, so I think this is all, everything had to come together because there's a lot of technology. And so I think the timing is just come together. And give you another example, a company I back called Via Imaging. They are doing 3D image sensor. So in a way, you can see 3 dimensions behind the wall. And if you go to airport, you have to put up your hand with a machine of 200,000. Now you can have just in your cell phone, I can scan the whole body in the 3 dimensions. And so, it's incredible. I mean, you don't have to do the diabetes blood test with the needle. And you can just wear the 3D sensor and then you pretty much know what you have and it can give you alert. And so those are the things coming. It's not in the future, it's already there. Basically, it's a microwave and frequency. And so those are the things that finally come together and the process capability can be small enough to do this. And so I think all in all, I'm excited about the industry and then this whole medical field is just a beginning.
And we're seeing it all around us. I mean, one of the nice things about the IoT is we actually touch it, right? Mm-hmm. It's our world, and we actually interface with it as opposed to a computer where you left it at the office and went home. Yeah. Although these days, people take it home and they never leave their computer. But as a consumer market evolves, another piece of this, one of the issues is how are we going to bring all this together? We have a lot of disparate technologies in the home. I think everybody has a basket of remote controls in their living room. Devices don't communicate with devices, or they do 80% of what they're supposed to, but don't quite get there. How do we move that needle forward?
You're talking about the home now, right?
Yes.
Okay. So I think the home is a very exciting, another big platform that a lot of people are starting to pay attention to it. And clearly on the Cadence side, we work with some of our customers, try to drive some of the unique requirements. And privacy is very important. And also some of the key performance within the house. And so that you can, just give you one example, like Wi-Fi. And then you may have the experience in the different room. And then if you keep playing some very intensive game, and all the bandwidth sucked to that side, and how do you optimize dynamically and in terms of the software to drive that and the silicon to drive that. So anyway, those are exciting things to me. But more exciting to me, I think, is the whole home security, and then also we call it the robotics, but it's a lot of more artificial intelligence built in. And so I'll just give you 2 examples I invest in. One is Canary. It's basically, if you go to Best Buy, you can see the box, and basically able to do the home security. And then with your phone so that you can be anywhere you can be in the world traveling. And so it's really exciting to see that security features that you feel safe, either your family members or your dog at home and then will be safe. And then the other part is the whole artificial intelligence robotics. So we also invest in the company called Rocket. If you go into the site, it's a lot of intelligence so that they know and recognize the family members, and then it's learning. They're learning the different, the kids, or you have a newborn baby, they're starting to learn the very intelligent. And then if there's somebody new coming in that is and not authorized, and the alert went off, and immediately alert you someone came in that is not authorized. And so those are kind of things that, and then they're going to do the control, remote control, or all the gadget at home that you have with beamforming, so that they can control up to 16 different devices. And so to me, those are the future, but it's not too far future. The product is already come out now. So it's exciting that home become, you spend so much time at home, you want to have all the gadget that's all in your fingertips, and you can do gesture control. You don't have so many remote control that you don't know which one to use. And I have a hard time to figure out which one, and whether it's my kid's remote control for something else. And so with this, it can be very personalized to what you need, go to different room. And those, I think, is very exciting to me. And also the other part is, seamlessly, flow through to your phone, to your work. And that's what I like about Tesla. All my favorite music from my phone, when I walk into step into my car, is come out the music that I love. And it's all my calendar is right out there. And that's why I'm kind of really excited about it.
I want to know what this robot does to strangers.
Yeah, you should find out. And you can program it, and then so that you can kind of give you the right alert to you.
Go from stunned to something else.
Yes.
Well, most of the processing, initially the idea was that we'd have a lot of dumb devices around, and they would all communicate through the cloud, which is very heavy I/O. The reality is that it's very expensive to move data, both in terms of power and performance, and just in terms of cost as well, time spent. Has that thinking changed, and how does that affect what goes into designs?
So you're talking about
whether it's
the data transmission in the multiple?
Whether it's done locally on board the device or remotely.
Yeah, that's a big topic, depending on how you try to expand that. So I think clearly, from the cellular side, there's a lot of effort into the 5G, and so there's more capacity, more speed, and I'm excited about it. I mean, we fund quite a few companies, and also on the Cadence side, we try to help our customer in some of this design. And then the other part, I think, is also a lot of more seamless Wi-Fi. Wi-Fi is everywhere. And then how to make it a kind of carrier class, the quality. And I also fund a company called Quantana, and then they're able to provide a carrier class and the Wi-Fi infrastructure. So I think those are exciting. So I think this is kind of more, the distance around here. And then, of course, I think the biggest challenge is how to the cloud. And then also cloud, there's a big change right now because so much data coming in, and then the data analytics and then the I/O become a lot more. There's a new suite of architecture changes to the cloud infrastructure, and basically is to really drive better performance on the storage, better performance on the networking. And so this is an entire sea change happening right now as we speak. And we are really excited to engage with some of this. And some of them, they had to build some of the custom and ASIC for the super hyperscale web service company. And then they are growing incredibly fast. And they invest a lot of money. And so with that is another great opportunity for the silicon provider, and also for the tool and EDA and IP provider. So those, I think, are going to drive the change in terms of everything is about the speed. And so any latency, slow, and people can put up with it. And especially the young kids, they don't have patience for it. So I think, we are working really hard to serve our teenager, and they demand a lot. And so, a lot of time I had to talk to my son. He said, "Dad, you do something about it. Why are you so slow? I mean, they are so anxious, and so many things they want to have an instant response, and but we just have to work hard to meet that requirement."
So the hourglass doesn't work with these guys anymore.
No.
As we start changing these things, though, we're really starting to rethink almost how computing is done everywhere, right?
Yes.
It's not just at the device. It's not just in the data center. It's granularity and Where do we have improvements all across the information chain, wherever the data flows? How does that affect design? What happens on the tools? Are the tools ready to take care of that? Is it a matter of using them differently? Is it a matter of we need new tools?
Yeah, I think the couple of areas on the tool side that we're excited about, but clearly the productivity, time to market, and time to design, and time to verify become very critical. And so clearly, this is something that anything that you can improve the performance power and area become very important. And then the other part is a lot of people don't pay a lot of attention to the runtime. And so how quickly can you design and well, rather than waiting for a long time. So any 2x, 5x, 10x is huge in terms of improvement, and that will help a lot of productivity. Our customer is crying for it. And then the other part is verification. Whatever you design, how do you verify that? And depend on different applications, like you mentioned about automotive, and then the home, and then the cloud infrastructure. They all have different requirements. And so clearly, from simulation to emulation, and then to formal verification become very critical. I think Jim Hogan talking about three-leg stool is very accurate way to describe that. You need all three, and also some of the IP that you use, how you need the verification IP to have that portfolio in place to put it together. So I think all had to tie in together, and that's why we are really excited to try to create this verification suite, and that we can really drive. And by the way, it's all connected also to the digital side. And so whatever you design, and then you make sure they have the verify together. And so that's why we decided to have Anirudh, my partner, to really drive both, because it's really hand in hand, and then to drive the solution that the customer needs.
While you're on that topic, is it, for a long time we've been shrinking analog at the same rate we've been shrinking digital. Is that going to change? Do you see them still going down the same path of we're going to 10 nanometers and 7 nanometers and 5 nanometers, or are we starting to rethink how everything goes together?
Yeah, I think it's very hard to, it's not a two silo, and a lot of time the design are mixed signal, and so you just have to really optimize on both sides, and we call it we have a mixed signal initiative, rather than digital analog, but somehow they have to work closer together. And even though I think you have assumption that analog you really don't need to push so hard on the advanced node, but clearly on our custom analog side, we're also pushing hard into the 14, 16, 10, 7 nanometer. And so, frankly speaking, I think it's all driven by our customers. And the customer, you have to anticipate what customer challenge is going to be. We have to be ahead of them to make sure our tools are qualified and optimized for them. So right now, like for example, a couple of key customers of ours pushing us really hard to the 7 and 5 nanometer. And we are responding, working really hard with them, double, triple, quadruple patterning and coloring. So we do everything we have able to provide them. And we are the kind of a solution provider. And then in terms of time to market, it's so critical, not just our tool, our IP, and then also work with our IP like ARM partners is critical, and to optimize some of the solution and tool we have, and also our foundry partners, and that are critical. And because at the end of the day, the customer looking at all three of us is all your fault. And if one of you don't perform, and we all get blamed. So we reach out to our IP partner, we reach out to our foundry partner. Hey, guy, we are serving the same customer. And our customer delight and satisfaction is our #1 priority. So we have to do whatever we take to make sure that we optimize. And then in the good old days, you just do your own part and you throw it to the other side. It's their responsibility, no more. So right now we have to be working very trusted, collaborative way to solve the problem for the customer. And I think that ultimately the system, the complexity increased so much, that trust level is going to be so important.
Well, we pretty much know who's moving to 7 and 5 nanometers, their household names. What's changed, though, is that the path forward for a lot of companies is not necessarily to follow them down to the most advanced nodes. So now they're rethinking at older nodes, what else do we do? And that's a fairly fundamental shift of what's gone on in the industry for many years. As that happens, how do you serve that market too, and how do you serve that one effectively?
Good question. So I think we are excited because we have big chunk of our business is more the analog mixed signal for the industrial. They are comfortable at 65, 40, 28, and
or 350.
Or 350, and so we love them, and so we continue to drive. And then, frankly speaking, from our learning curve from the 10 and 7, some of the technique we also can apply and then optimize for them. So again, it's collaborative with the customer, and we have deep trusted relationship with our customer, and we work very close with them, try to drive the productivity, the performance that they need, so that they can win in the marketplace. Then they're going to buy more of our tool and IP, and that's kind of a vicious circle. And then the other part is, clearly, we also kind of try to point to them, and in a lot of time they're asking us, should I, especially some of the digital player, should we go into 7 nanometer? And then what's the advantage, what are the power, and what's the cost associated with that? And then, or should I just stay at 28 or move gradually to 16 and 14? So those are very common discussion we have with our customer. And because many of our customers treat us as a partner, not the EDA vendor. And because we are helping them in their product strategy because of my unique position, and also where the market go after market. And also I'm very close to their customer. So in a way, they kind of reaching out to me, said, well, Lip-Bu, you know all this stuff, what do you see, should I do this, should I not do this, and what are the trade-off? And so those are the discussion I love, because that's where we truly become their true partner, they can trust us, and then along the way, we can help them to plan, and because we've seen a lot, and so that we can tell them what their customer need, and then in the way they can influence their decision on their architecture design. And that part, I think, differentiates us, and then we kind of have that and enjoy that relationship with our customer.
Has that discussion changed in terms of who you're talking to at these companies?
Yeah, so clearly, a lot of time, beside, we basically work as a one team approach. And so if you look at my organization chart, it's a circle. So each function, the leader are my partner. So even though they report to me, but they have no hesitation to brainstorm. And so we work very closely like a team. Just like right now, the basketball team, the playoff NBA, and I'm a big fan of Warriors. I go to every game. So the key thing is, when they play at home. So if you're traveling to Cleveland, I won't go there. And but I think it's more important, it's a team approach to the customer. So we basically provide the customer a whole team, and then how can we work with them to help success?
How about on the other side, though? I mean, how is the customer approaching Cadence? Is it the head of engineering? Is it the CEO now who's making the decisions that they were not in the past?
Yeah. So back to your question. So we have a multiple tier with the customer. I should usually deal with the CEO and the top executive, and also the guy that running the engineering. And then my team working with their EDA manager, and then make sure that we optimize whatever requirement. So in a way, we work really in hands together from the business point of view, from the tool point of view, and from the go-to-market point of view. So with a very holistic way of working with the customer.
We were talking about industrial here, and one of the things about industrial is there is a very clear ROI on whatever they're investing in and putting in technology and some connection to a smart device, so they can tell if an assembly line's broken or some sort of fluid is not flowing through a valve. But each one of these devices is very purpose-built, they're very individual, and they all have to be, to some extent, low cost.
Yes.
How do you design for that, and how does that change versus what you're doing in a lot of other markets?
So your question is more specific to?
Industrial.
Industrial. Okay, good question. Industrial is a very good business, and I like them a lot. And because clearly, they have a very different requirement. Cost is very important, and also the productivity is very important to them. Either it's a big factory, and they have multiple production line. They want to know exactly where the design and the pieces they need to know, and the data become very important to them. So they have different requirement in terms of power, performance, and so we work very close, and most of them are mixed signal requirements. So in a way, we are in a very sweet spot. We work very close with them, and various industrial group, and we mentioned in our earnings script, General Electric work very close with us. And so in a way, they have multiple vertical market. Along the way, we learn a lot about their requirement and then what is critical for them. Either it's a safety, reliability in the aviation side, or the industrial, automotive related, and the medical. They have a completely different requirement. So along the way, we learn a lot, and then we basically try to take an approach of stay humble, learning with them, and then in the way we have a lot to learn from their industry. The more we understanding the industry, we can help them to design what they need. And so, either it's a tool, design, the IP, and the verification, or some of the software stack that they need. And so, along the way, I think it's very beneficial and to learn from them, and they also learn from us and appreciate what we can offer, and rather than just a tool vendor, and that's kind of boring.
IP's been a big growth area for basically the whole EDA industry, partly because you guys have bought up a lot of the IP companies. Will that continue to be a huge growth engine in the future, or will that change?
Yeah, IP is a very interesting business, because if you deal about the system on the chip, SoC, there's a lot of IP block. And big company in the past used to be owning all the IP. But as you know, the IP, the protocol, the standard keep changing. It's become harder and harder to maintain and keep all this up to date. And so it's a little bit like EDA 25 years ago. They tend to starting to be outsourcing out for the people. If you have a couple of things. One, silicon proven, reliable quality IP. I think that is the biggest challenge for the industry. And because silicon proven, high quality IP is critical. Because customer, they can deal with just tool with bugs, but they cannot deal with the tool, IP with bugs, because it hurt their production, hurt their revenue, and they will scream at you very loud. And so I think that part, we are still learning, how to become a really good silicon proven and continue to drive the standard, drive the protocol, and then meet the customer requirement. It's a great opportunity, and it's a double-digit growth area for us. And then we continue to build organically, and also acquire pieces that we think is worthwhile. So I think follow our history. We focus on the memory first. Then we bought Tensilica. It's a great IP because it moved into the machine learning, deep learning, ADAS, because it's programmable. There's a lot of application. We're going to double, triple down on it. And then there's some other IP that we're quietly building and acquiring. And so I think we're listening. At the end of the day, we listen to customer. Customer tell us which one to buy, and then which one not to buy, and which are the challenging one, and they try to avoid until we're ready. And so, again, it's a 20 years business, so you just take one at a time.
I'm running out of time, but I want to ask you one more question here. As we look at design these days, hardware companies are being forced to develop, or not being forced, but they're being told that they have to develop much more software if they want to win a slot or a position in a deal with any of the OEMs or systems vendors. The software problems seem to outnumber the hardware problems by quite a bit. The number of people that are going in tend to be more software engineers and hardware engineers these days. People are learning much simpler things like Python, languages that are much more sexy and taught out of school. As that starts shifting there, as we start getting more of those guys into this industry, will the software in the future define the hardware, or will the hardware still always have a play in the software?
It's a big question that you're asking. Let me try to answer a couple of areas. As you know, right now, it's a lot about software-defined, storage, network, almost everything is software-defined. And so I think clearly, if you talk to 9 out of the 10 of my customers, they hire more software engineer than the hardware. So that is a fact. And I think that 3 problems we are facing, and at least our customers are facing. One is that the best software talent sometimes don't come to our semiconductor sector. And I have my 2 boys, they are double E in computer science, and they decided to go with software. The Salesforce.com, the Google of the world. And so for semiconductor company try to attract the young, bright software engineer is hard. And so we try very hard to compete with Google to get those talent. And then the same thing with our semiconductor customer, and they're all facing that. And then secondly, the software for our customer, even though they put a lot of effort, the ROI is not that good, because you know why? The customers still view them as a hardware company, semiconductor company. You cannot charge extra. And so you basically, you can maintain your price, but throwing a lot of software, and you're lucky. And that is something that all our customers are facing, and we are working with them on that. And so I think saying that, I think there's a great opportunity. There's a couple of our customers are trying differently. And I think you heard our friend NVIDIA and Qualcomm, they're starting to define themselves as a system company than a semiconductor company. And I think they're right. I mean, if you look at NVIDIA, right now they are a very strong system company. Automotive, you go to every single automotive company, you open up, is NVIDIA chip inside. And so it's very powerful, and it's very smart. And Qualcomm also doing something along that line in different extent of success. So I think you kind of see a couple of companies starting to move successfully to the system level, and then able to monetize some of the software effort they put in. And so again, we are trying to work with our customer to fine-tune what are the software that we can charge per unit or per loyalty or like IP. And so those are the things just working through. And we all have different journey. We have to different defining of how do you monetize some of the software. And we're all going to try, and then with some different level of success. And I think that's a fun part of our industry, that we just have to learn what work and what stick, and you double down on it.
Thank you very much.
Thank you.